So until now, we have checked out the associative property of rational numbers. Now, below this, there is a table that summarizes the associative property of various kinds of numbers. So, in case of rational number, in case of addition, we saw that associative property is being followed. In case of subtraction, it was not being followed. Associative property was not being followed. Okay, in case of multiplication, associative was property for rational number was being followed. Next, in case of integers, we found yes, it was being followed. For subtraction, associative property was not, and for division, also it was not being followed. Next, for whole number, we find that for addition, it was being followed. For subtraction, no, it was not being followed. For multiplication, it was being followed, and for division, it was not being followed. For natural numbers, we could not see. So, just we will try to ascertain our whether it is being followed for addition, subtraction, multiplication, and division or not. Okay, so we take some natural numbers 1, 2, and 3. Okay, natural numbers. So first we see for addition. Okay, so in first case we write it is in the form of 1 bracket 2 plus 3. So answer is 6. Now if we group in other form, we are grouping first 10, second, and keeping third away. In this case also we will get 6. So it will be natural number will follow associative property for addition. For subtraction, it is saying no. So we will just verify, okay? We will just change plus sign to minus sign in the examples, okay? So second, 1 minus 2, 2 minus 3. Okay, what will be your answer? That is 1 minus inside bracket minus 1. So 1 plus 1, and it is 2. And just we will change our bracket 1 minus 2 inside bracket minus 3. So in this case what we will get 1 minus 2 is minus 1 minus 3, that is minus 4. So minus 4 is not equal to 2. Okay, LHS will not be is not going to be equal to RHS. Okay, so it is no. So no, not following. It is already failed here. No. In case of multiplication, we will see with our example 1, 2, and 3. So 1 multiply sign, then inside bracket 2 into 3. How much we are getting? 6. 1 into 6. And if we change the bracket, position of bracket, okay, we will keeping third one outside. In this case also we are getting 6. So yes, for multiplication it is being followed. For division we will check. We will write 1 divided by 2 and 3 is in bracket. Okay, what we are getting here? 1 divided by 2 by 3. So in second step 1 into it will be reciprocal. So 3 by 2. Answer is 3 by 2 for LHS side. For RHS side, we will change the position of bracket or grouping association. Okay, by 3. Okay. So we will solve this will be 1 by 2 divided by 3. So 1 by 2 into 1 by 3. So we will get 1 by 6. So clearly 1 by 6 is not equal to 3 by 2. So no. So we can see the pattern for addition, associative property is being followed for rational, integers, whole, and natural numbers. And for multiplication, it is being followed. And for subtraction and division, it is not being followed. So simple. Okay. Now moving to next, there is one example. Find 3 by 7 plus minus 6 by 11 plus minus 8 by 21 plus minus 5 by plus 5 by 22. Okay. So in the first method, when we see such example, what the first method that it has been shown here, they are simply adding these numbers. Okay, they're not changing anything to it. Okay, simply adding. So first of all, we will get LCM of these four numbers. Okay, 7, 11, 21, and 22. So what will be the LCM? 7, 11, 21, and 22. 7, 1 ja, this is 11, this is 3, this is 22. Then 11 times, this is 1, this is 1, and this is going to be 3, and this is going to be 2. Okay, so 7 into 11 into 3 into 2. Okay, how much? 77 into 6, that is 42, and 42 plus 4, that is 462. So we have LCM as 462. Okay, now we will write it as 462. And 3, how many times we are 7, how many times we are getting 462? So we will multiply 3 with that. So 7 6 are 42, and 7 6 are 42, plus minus 6 into 11. How many times is 462? So 11, 4, and 2, plus minus 8 into 21. How many times is 462? So 20. It is 22 times. 22 times. For 22, how many times is 462? 5 into 21 times. Okay, 21 times. So it's going to be 198 plus 9 bracket inside bracket 12 and minus 252 plus 176 minus, because minus sign is there, plus this one was, I think, 5 into 21. It is 105 divided by 462. If we add these numbers, here's 198 minus 252 minus 176 plus 105, we are getting 125 by 462. So just simply we solve this equation. Now a below example you see. You can solve this. We know that associative property works for addition in case of rational numbers. These all are rational numbers. So we will group the numbers. Okay. We will group the numbers. Okay. So how grouping is done? So you see here how grouping is done. 3 by 7 plus minus 8 by 21. Okay. We will get easily LCM as 21. 21. So 7 3 are 21. So 3 into 3 9, and 8 21, 1 are 21, so this will be minus 8, nothing will change. Similarly, 11 and 22, LCM is 22. So 11 twos are 22, 6 minus 6 into 2, we will get 12. plus 5. Okay, so simplifying this one, we will get 1 by 21, and simplifying this one, we will get 22 by minus 7 by 22. Now we can easily find its LCM as 22, and 21 is 462, and 21 into 20 times, 22 times, so 1 into 22 times, 22 into 21 times is 462, so minus 7 into 21 times, that is minus 7 into 21 times, that is minus 147. So we get this result easily. So we can find, by using associative property, we have simplified our mathematical ऑपरेशन, है ना, इसमें अपने को कम दिमाग लगाना पड़ा ना। तो व्हाट इज आवर लर्निंग, है ना, हम लोगों ने ये सब कुछ इतना पढ़ा, है ना। तो इससे लर्निंग क्या है ना, इससे लर्निंग ये है कि हम एसोसिएटिव प्रॉपर्टी पढ़ के हम ये समझ सकते हैं कि कैसे अपनी इक्वेशन को इजी करना है, कैसे मल्टीप्लिकेशन को इजी करना है। सपोज कीजिए 21 इंटू 22 है ना, 21 इंटू 22 है, तो इसको हम कैसे सिंप्लीफाई कर सकते हैं ना। इस हमने कुछ सामान खरीदा, 22 रुपए का 21 सामान खरीदा, है ना, 22 रुपीज का 21 सामान खरीदा। अब अचानक से हमारे दिमाग में आता है, तो हम कंफ्यूज होने लगते हैं। तो इसको सिंप्लीफाई करने के लिए हम क्या करते हैं, 21 इंटू 20 + 2 ऐसे मैथ्स में दिमाग में कैलकुलेट करते हैं मेंटली। ओके, सो दिस इज गोइंग टू बी, वी कैन इजीली फाइंड दैट 21 इंटू 20 इज 420। सो हमारा कुछ खर्चा 420 रुपए के आसपास आएगा, एंड 21 इंटू 2 इज 42, है ना, तो टोटल इज 462, that is a LCM, that was the LCM. Okay, so by why are we studying these properties, associative property and other properties? What is the use, commutative property, associative property, what is the use? Okay, when we we use them to simplify our equation, है ना? So do you think that properties of commutativity and associativity made the calculation easy? Okay, now there is other example, minus 4 by 5 into 3 by 7 into 15 by 16 into minus 4 by minus 14 by 9. Okay, so if we are going to solve without making any change to equation, you can see it is going to be complex. Okay, the first example has shown that only. Okay, they have solved it just like first they solved this one. Okay, so minus sign they have taken out, so it is going to be 12 by 35, and second part they are solving this one. Okay, so 15 into 14, we have to do the calculation of 15 into 14. It's a uh, difficult multiplication, and then 16 into 9. Okay, so they have multiplied it here. That's somewhat simplified. This is going to be 2 8s and 2 7s. This is going to be 3 3s and 3 5s. So 35 and 24. Okay, and in this one, this will cancel out, and this one and this one will cancel out. So 1 by 2. Okay, so this is, we have not changed the position, but if we we know that multiplication follows commutative property for a rational number, so we can commutate, we can change the position of these numbers. So if these are A, B, C and D, we can change their number using commutative property. And commutative property, we can change their number. Okay, so we just change their position. Sorry, we change their position. Okay, so we can see that minus 4 and 16 they will cancel out. 5 and 5 they will cancel out. Okay, so we will group these two, A and C, together. We group them here together, and we can see B and D have something common in numerator and denominator. So we grouped these two numbers here. Okay, we group them here. So this one is, and this one will cancel out. 3 4 times. So simply we'll get minus 3 by 4 here, and 7 and 14 cancel out, and 3 cancel out. So minus 2 by 3. So we are getting again this one and this one will cancel out, and this one will cancel out. So we have simplified the solution. We didn't have to involve in bigger multiplication. For example, here we have to multiply bigger numbers, and by using commutative property, how we use commutative property? We have shifted, commuted, and then we have associated. We have formed group association of similar numbers, or the numbers which we found that our calculation is going to be easier. Okay. Then next 1.2.4 is role of 0. Okay, 0 is hero. Look at the following. 2 plus 0 is equal to 0 plus 2. That is 2. So addition of 0 to a whole number we are doing. Okay. Then minus 5 plus 0 is, if we exchange the number 0 plus minus 5, then also we are getting minus 5. Okay. Addition of 0 to an integers. Then rational number minus 2 by 7 plus 0 is going to be equal to 0 plus minus 2 by 7, that is minus 2 by 7. Addition of 0 to a rational numbers. Okay. You have done such addition earlier also. Do you do a few more such addition, hai na? Or you just take out your notebook and do such addition. So what will you find that? You will find that when you add 0 to a whole number, the sum again is a whole number. This happens for integer and rational number also. You added 0 to a whole number, you get a whole number. You added 0 to an integer, you got an integer. You added 0 to a rational number, you got that rational number itself. So 0 is called identity for addition of rational numbers. It is additive identity for integers and whole number as well. Remember this term, additive identity means adding 0 to any number is not going to change that number. Okay, it's not going to change its identity. The number is going to remain as same. Now the role of 1. We just learned the role of 0. 0 is called additive identity. That if we add 0 to any number, integer or whole number or natural number, it is going to be same thing. Nothing is going to change. Similarly, the role of 1. After 0, we will learn the role of 1. So if we multiply any number with 1, it is going to have no effect on that number. We multiply 5 with 1, so this have, or we multiplied 1 with 5, it is going to same. And we multiplied minus 2 by 7 with 1, it is going to be 1 into minus 2 by 7, nothing is going to be changed. Same result. Okay. And 3 by 8 into 1 is equal to 1 into 3 by 8 into 3 by 8. Okay. So what do you find? You find that when you multiply any rational number with 1, you get back the same rational number as product. And similarly, we checked it for other number also, like is natural number, whole number also. So 1 is going to be called as 1 is the multiplicative identity for rational number or whole number or natural number. We simply call 1 is multiplicative identity, that it is not going to change anything. Similarly, 0 is additive identity. Think and discuss and write. If a property holds for rational number, will it also hold for integers, for whole number, which will and which will not? Okay, we will try to solve this and think on this first, we later, and now we are going to discuss this next property, that is distributive distributivity of multiplication over addition for rational numbers. So first you try to think on this. Okay, pause this video and think on this. I will come back to it again. Then, as the name suggests, distributivity of multiplication over addition for rational numbers. Okay, so to understand this, consider rational number. We have taken three rational numbers, suppose A, B, and C. Okay, A, B, and C. Here A is minus 3 by 4, B is 2 by 3, and C is minus 5 by 6. So we are learning distributivity of multiplication over addition. Okay, so we have kept B and C under addition, and we have kept A outside that addition. So here multiplication is being distributed. It will be, if we open the bracket, it will be A into B plus A into C. Okay, so we see here minus 3 by 4 into 2 by 3 plus inside bracket minus 5 by 6. Okay, so if we are first we are solving this equation in the form of brackets. We are not opening the brackets. Okay, so inside bracket the 3 and 6, the LCM is 6. Okay, so 3 into 2 times is 6, so 2 into 2 we will do, and 6 into 1 times, so 5 minus 5 into 1. So result is minus 1 by 6 inside bracket. So if we open up the bracket, what we will get? 3 minus 3 and this 6 will cut out, and minus sign will cut out positive. So we will get 1 by 8. 1 by 8. 4 into 2. Okay. Now also the in this example we simply solve this number in the form of bracket, but here it is being distributed. Okay. Minus 3 into 2 by 3. How much? It is going to be 1 by minus 1 by 2. And similarly, minus 3 by 4 into 5 by 6. They have distributed. From here you see A into B, they have here we have done, and then we are doing A into C. A into B, how much we got? Minus 1 by 2. And A into C we will see minus 3 by 4 into minus 5 by 6. How much it is? Minus 5 by 8. Sorry, 5 by 8. And so if we add these two, minus 1 by 2 and 5 by 8, we are getting 1 by 8. 1 by 8. Same result. Okay. Same result, as we have not opened the bracket. We solved in the form of bracket, and we opened the bracket and then added their products. Okay. Thus, minus 3 by 4 is writing in the form of ABC. A into inside bracket B plus C is equal to A into B bracket plus A into C. So you see the multiplication is being distributed over addition and subtraction. It is called distributivity of multiplication over addition and subtraction. For all rational number A, B and C, A into B plus C is equal to A plus B, A into B plus A into C, and A into bracket B minus C is equal to A into B minus A into C. Okay, that this is multiplication is being distributed over addition or subtraction. This property will also help to solve equation easily, do calculation easily, that we will see. Now next there is example to be solved. Find using distributivity. Okay, minus 7 by 5 into minus 3 by 12 inside bracket, then addition bracket inside bracket 7 by 5 into 5 by 12. This example. Okay, we have to solve this. Okay, so if you can see, you have to go in reverse form. Okay, if you take out 7 by 5 outside this, what will we get? We are just taking 7 by 5 outside. 7 by 5 into minus. We are going into reverse engineering. From here also we will take 7 by 5. This plus sign will be there. 5 by 12. So denominator is common. So we can write 7 by 5 into 12 minus 3 plus 5. 7 by 5. 7 by 5. 2 by 12. Equal 6. So minus 7 by 30. We have simplified. We have simplified. If we had gone in just this way, it will not be that easy. However, we will just find out whether this is going to come same answer or not. So 7 by 5 into minus 3 by 12, nothing we can see common. So it is minus 21 by 60 plus bracket close. It is going to be 35 by 60. 60, you get common LCM 60 minus 21 plus 35, that is okay, that is 35 minus 21. 35 minus 21, that is 24 by 60. No, 14 by 60. So it's going to be, if we divide by 2, 7 by 30. 7 by 30. Okay, 7 by 30, and here we are getting no, we will not get minus sign here. Minus sign is not there because 5 minus 3 is 2. Okay, so minus 1 to 7 by 30, 7 by 30 both side we are getting. So we just reversed back the distributivity property. Similarly, for this example, we'll find out. We will first go by the bracket, how what bracket is saying. So first we will solve this term. Okay, so this term is going to be this bracket. If you solve, we are cancelling by 3. Okay, so bracket term we are getting 3 by 16 plus this one is going to be cut out. We are getting minus 3 by 16. Okay, so it is going to be 0. Okay, and if we are going to take common terms, if we solve by taking out common terms, what will be that? We will take out 9 by 16 as common, and then 4 by 12 minus 3 by 16. Something is going to be wrong. Okay, let's erase it and solve it again. First, we will go by basic method. Okay, 9 by 16 into 4 by 12, cut out by 3, and plus 3. So 3 by 16. Bracket we are getting 3 by 16 plus this bracket 9 and 9 will get cut out, minus 3 by 16. So it is going to be 0. This we solve by general without any manipulation. Now we will take 9 by 16 common. This is going to be 4 by 12, 4 by 12, and this is going to be plus minus 3 by 9. Okay, so it is going to be 1 by 3. This is going to be 1 by 3. So 9 by 6 into 1 by 3 plus minus 1 by 3. So this is going to be 0. 9 by 16 into 0. So anything multiplied by 0 is going to be 0. So 0 and 0 LHS is equal to RHS. We just went in reverse form of distributive property to get our results. Hope you understand this. Now there is another one example, 2 by 5 into minus 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 7 into 3 by 5. Okay, so if we were going to solve it without doing any changes, what is going to be done? So first we will simplify it. This term has been simplified. You can see this one is not simplified. This one is simplified. So we can see 7 and 14. So we can divide it in the form of 7. Okay. So minus 2 by 5 into minus 3 by 7. This one term we have written simply. Then minus sign is there. Then 1 by 14 can be written as 1 by 2 into 1 by 7. Okay. Then minus, we will simply write this 3 by 7 into 3 by 5. Now, one thing we are seeing common in these groupings, this grouping, and this grouping, that is 7. So we will take 1 by 7 outside. 1 by 7 outside. So we can write it as 2 by 5 into minus 3. Okay, 2 by 3 into minus 3 minus bracket is 1 by inside 1 by 2. 1 by 7 we have taken out. Okay, then minus inside bracket 1 by 7 we will take it out. So 3 into 3 by 5. Okay, so 1 by 7, it will be minus 6 by 5 minus 1 by 2 minus 9 by 5. Okay, so LCM will be 10. So minus 12 minus 5 and minus 18. Here we have having 1 by 7. So 1 by 7 into 10. Upper term we are getting 30%, 35 minus 35. Okay, this will 7 35 and 5. So we will get minus 1 by 2. Minus 1 by 2. Okay, so we have simplified our calculation. Now we will see what they have done in this solution, what the book has done. Okay, this was one term, this was another term, this was third term. Okay, so it has, by using commutative property, it has shifted 1 by 14 here and 2 by 5 into 3 by 7, and this term it has shifted here. Okay, after that it has taken minus 3 by 7 as common. Minus 3 by 7 common. You can see after shifting this minus 3 by 7 from this grouping and 3 by 7 from this grouping was taken out. Okay, was taken out. After that, what is left? 2 by 5 plus 3 by 5. Okay, so minus 3 by 7. This equals to 1 minus 1 by 14. So it has used as another method. Okay, it has used as another method. We have used another method. Okay, so you got to understand two methods of solving that equation. Now exercise 1.1. Okay,